Okay, now we're going to use the vocabulary from our tangents section of our textbook to start solving some problems. The first problem that you see in your book, example 1 there, says that if ED is tangent to circle F at point E, then we need to find X. So of course the first thing that we know is that if it's a tangent, that the radius drawn to that point of tangency is going to be perpendicular. So we've got a right triangle on our hands. So you guys, we are going to be using that good old Pythagorean theorem again. And I hope you can see the triple here. Okay, so we know that x is 5, but if you can't see it, remember we can always go back to Pythagorean theorem. So we've got 3 squared plus 4 squared that is going to equal x squared, because x here represents the entire hypotenuse, notice, all the way from F to D. So if we go ahead and solve that, we have 9 plus 16 equals x squared. X squared has to equal 25, and then of course x is 5. But again, please, come on guys, memorize those triples, okay? Especially at this point, we've worked with them enough in this section and in previous sections of our circles unit, as well as in our right triangles unit, that I hope you know that those triples are really important to know. Okay, moving on to our next example, same type of problem. This time we have RS that is tangent to circle Q at point R, and we're asked to find Y. So again, because it's tangent, we know that this angle R here is a right angle. I'm going to call the QR portion, we're going to call that R because it's a radius, so that makes sense. But I think you can see that Y is the diameter, so once we find R, we are going to find Y by just doubling it. But if we have Pythagorean theorem at play here, R squared then plus 16 squared is going to equal 20 squared. And if we do R squared plus 16 squared is 256, is going to equal 20 squared, which is 400. A quick subtraction gives me 144 for R squared, and then R is 12. So remember, we need to take that 12 and we need to plug it on in over here into that equation. So once we know R is 12, Y has to be 2 times 12, or 24. Pretty simple. Another way to think about this is if we look at the 16 and the 20, which are two sides of that right triangle already, we can see that they have a common factor of 4 themselves. So if I thought about what other number would go with the 16 and the 20, if we thought of this as a triple that needed to be filled in here, and we went and divided by that common factor of 4, the 20 would lead to a 5, the 16 would lead to a 4, and oh look, there's that 3, 4, 5 triple again, multiplying back by multiplying by 4, you get 12 for that R. So again, Pythagorean triple coming into play. So that's finding lengths. On the next slide, we're going to be talking about proving whether a piece of a segment is actually tangent to a circle or not. And in that case, we are going to definitely want to use Pythagorean theorem again. But the question is, we're going to be looking for if something is tangent, then we know that the Pythagorean theorem is going to work, meaning that we're going to get the same exact number on both sides of the equation, okay? So as we look at this diagram, I hope you can see here that because LM and LO are both radii of the circle, that it makes sense to put that 3 in for the length LO as well. And so at this point I have a 3 here, a 4 here, and if I add those pieces together, we've got a 5. So again, we see our Pythagorean triple coming into play. We're just going to verify it, and I do need you to show me this in your work, even if it is based off of a 3, 4, 5 triple, which you should know in your sleep by this point. I do need you to show me these quick steps. Won't take long. The question is, was that a triple that worked out? And the answer is yes, 25 does equal 25. So just show me those steps and then we can make a quick answer of absolutely these are tangent. Next example, kind of like it, not in your textbook. This time we're determining whether BC is tangent to circle A. And so again, it looks like they've labeled all the pieces that we need. So the question is, does Pythagorean theorem work? And so we would ask, does 7 squared plus 9 squared equal 14 squared, adding those two 7s and squaring them? So 7 squared is 49, as you know. 9 squared is 81, as you know. And 14 squared, is 196 if we were to do that with a calculator, or hopefully you have those perfect squares memorized at least up that high. So we're going to add these two sides, these two numbers on the left-hand side together, and we get 130. And that is definitely not equal to 196. So in this case, we have to say no, they would not be tangent, and therefore that's why the right triangle would not work out for us.